So here we have a very complex looking problem. This one is going to be a combination of rules. And some of you are going like, wait, we just talked about combination of rules. When we talked about combination of rules, when it had to deal with just the product and the quotient rule. Now we're going to be talking about combination of rules, adding power rule to the other two. You're going to see this one more time, and I'm going to add another rule. So it's going to get longer and longer as we go. So I'm changing some of the ways we handle the product and the quotient rule. So let me go over these steps first, and then we can go over a couple sample questions. Now this is again combination of rules. You're going to see things that are power rule and quotient rule and product rule. So once you see more than one rule, we're going to be using these rules. The first step is just to make sure that every coefficient, constant, variable has an exponent written. So if you don't see an exponent, there's always an understood one. The second step is we want to do the power rule next, okay? We didn't have the power rule until today. The power rule is used to help remove the parentheses. How? We're going to be taking the outside exponent and distribute to all inside exponents. We're also going to distribute that outside exponent to any inside and negative signs, okay? We showed you that in our first video, that if you have a negative inside the parentheses, make sure that outside exponent is distributed to it. Remember, if it's an even exponent, then the negative is going to disappear. And if you had an odd number exponent, the negative is going to stay. Once we get rid of those set of parentheses, then we're going to do the product rule and the quotient rule. We can do these two together if you do it this way, by asking the two questions. So what you're going to do is, where do you have more like bases? Okay, so you'll notice that you'll have some like bases. You ask yourself, where do you have more? If you have more on top, then you're going to keep the base on top. If you have more on the bottom, you'll keep the base on the bottom. Then you're going to ask by how much more, okay? That will be a number that you're going to use for that exponent. And finally, for any coefficients or constants, see if you can simplify and reduce them, right? And remember, anything that's like a small number, like 5 squared or 3 cubed, those are small enough that you can simplify by multiplying out. So let's take these rules and apply it to this guy here. So the first thing you want to do, as I said, notice that we have a combination of rules. We have an outside exponent and inside exponents. Notice that we have the same letter here and here and here and here. So we at least have two different rules here. We have the power rule, and technically we have the quotient rule. Once you know it's a combination, step one, make sure every item, remember, coefficients, constants, and variables, make sure every item. So notice this 4 doesn't have an exponent. It's a coefficient, so slip in 1. Notice this 5 down here. It's also a coefficient, and you don't see an exponent, so slip in a 1. For this A, slip in a 1, and this B, slip in a 1. So notice every item, every letter, every number. This is still considered a monomial. Why is this considered a monomial? Because you do not see any addition or subtraction symbols. So we're allowed to do the second step, power rule. Power rule says we can get rid of these parentheses as long as you take this outside exponent and distribute to all inside exponents, and if there was any negative signs out in front of this, but inside the parentheses. So we're going to distribute this to this, to this, even to the bottom. Notice you're only distributing to exponents or signs, not to any of these bases. So do not say 4 times 2 is 8 or 5 times 2 is 10. You're not doing that. You're only distributing to the exponent. So I'm going to draw my fraction bar and say 1 times 2. So that means 4 would stay. Remember, the base stays for the power rule, and just multiply. 1 times 2 is 2. 4 times 2 is 8. Keep the same base of A. 3 times 2, keep the base of B, and you have a new exponent of 6. And you also do it to the bottom. Remember, this is version 3 of the power rule. 1 times 2 is 2. 1 times 2 is 2 again. And 1 times 2, 2. Now you notice that we do not have any set of parentheses. The next step that you want to do is ask yourself for like bases. Do we have some like bases? Yes. A's match, B's match. Then you want to ask yourself the 2 questions. The 2 questions, if you forgot, for like bases, where do you have more of them? So let's start with the like base of A. Notice I have A's on top, A's on the bottom. How many on top? 8. How many on the bottom? 2. Where do I have more A's? Top. By how many more? 8 versus 2, extra 6. Remember, we're subtracting, not dividing. Remember, there's 8 here, 2 here. When you cancel out, 2 from top cancels 2 from the bottom. 6 still are left on top. How about the B's? We got some on top, some on the bottom. Where do we have more? 6 versus 2. We have more B's on top, so I have to put the base on top. See how it's on top of the fraction? Then, how many more? 6 versus 2. Remember, if we're doing this, you're subtracting. So 6 minus 2 is 4. Now notice 4, there's no other base that's 4. So it was found on top, it stays on top. And how about the 5? There's no other 5s here. Found on bottom, stays on bottom. Almost done. 4th step. Do you have any coefficients or constants? If you do, see if you can simplify and reduce. For example, you know what 4 squared is. That's 4 times 4. So you have 16. You know what 5 squared is. 5 times 5, which is 25. This cannot be reduced any further, because if you try to break down 16 to reduce as a fraction, it is 2 times 2 times 2 times 2. If you try to break down 25, it's 5 times 5. Nothing will cancel out. So something that looks like this, we can simplify it with the 4 steps to make it look like this. I'm going to do one more of these, and then we'll do our sample question. 5.2 is not bad of a section. It's just learning about the power rule and then just incorporating that with the other 2. So this one has a C in it. Don't let that bother you that it has 3 different types of letters. Okay, so we know this guy is going to be the combination rule. You might be saying, how did I know that? Well, because you have more than one type of rule. You have an outside exponent and an inside exponent, so you know that's power rule. And you have the same base on top of each other. So that's the quotient rule. So we at least know that this has 2 rules. So the first step is to make sure every item, that means any letter, has an exponent. But if you don't have a letter, a variable that has an exponent written, write in a 1. Write in a 1. And then when you get to any coefficients or constants, if you don't see an exponent here, they also have an understood 1. So that's step 1. Step 2, outside can be distributed only to inside exponents. If you have it on top and the bottom, the fraction bar is inside the set of parentheses, you have to distribute it to both the top and the bottom. That's version 3. Also, if there was any negative signs here, then you have to distribute this to the negative sign as well. This guy, we're only going to distribute to exponents. Okay, so I do not want you to take this 2 and distribute to the base, only to the exponent. So you should not have a 10 down here. You should have 5 squared, which you know is not 10, it's 25. So when I multiply 3 times 2, we get A, remember keep the same base, 6. 5 times 2, B to the 10. C, 1 times 2, 2. For the 5, remember that's at the bottom, so the 5's at the bottom. 1 times 2, exponent times exponent only, 2. A, 1 times 2. And then B, 3 times 2. Okay. Once we're done that, our third step. Do you have any like bases? Do you have the same letters or the same base? Yes. A's was A's, B's was B's. So once you know you have the same base, we know that the step 3 asks you those 2 questions. For the base of A, where do you have more of them? I have 6 on top, 2 at the bottom. So if you have more on top, I got to put that base on top. Then I ask my second question, by how much more? There's 6 versus 2. That means there's an extra 4 of them up here. Remember, we're subtracting. We also have the same problem with B's. See how we have the same base? We have a B here, and we have a B here. Where do we have more? Top or bottom? 10 versus 6. There's more on top, so I put the base of B on top. By how many? 10 versus 6. There's an extra 4 on top. Now notice that there's no C's besides this upper corner. So you got to keep that C on the top, and it still stays 2 because there's nothing at the bottom to cancel it out, and there's no C's on top to combine them with. Notice this 5. There's no other bases that are 5s. So it was found on the bottom, stays at the bottom. Now that you have this, our fourth step, do you have any constants or coefficients? If so, try to simplify and reduce. 5 squared, you know what that is. That's something small enough that you can simplify. So our final answer is going to be A to the 4th, B to the 4th, C squared, over, all over, 25, because 5 squared is 25. So as long as you can do those 4 steps when we're doing quotient, product, and power rule, you should be fine. Remember those steps because we're going to add to it when we get to the section 5.3.